Um, haven't gotten to do that in a while.
Nice. Congrats. Record started. I did it.
All right, cool. So Tyrel tonight is going to talk to us about GeoDjango. So Tyrel, you can go ahead and get started.
Nice. All right. Well, I'm going to do all the screen share shuffling. So you have to bear with me. I'm also going to try and clean up my desktop or sweep everything under the rug visually.
You need my, when we do our dot file sweep?
Yes. I need that
script that cleans the desktop. Yeah.
I need that script.
Bathtub.sh.
There it is. It's a little different than the web guy versus sales dude.
Yeah, it's the opposite of that.
Yeah. So I think, no, that's not the one I want. On this one. So, nope, don't push that yet. Sorry. Share. All right. Okay. Cool. So can everyone see a nice PowerPoint slide there?
What in the world?
What in the world, indeed. What in the world happened to my mouse? That's a better question.
The Python ate it.
No kidding. There it is. It's back. And there I am. So, hey guys, for any of you who don't know me, which is a couple of you, I think, my name is Tyrel Denison. I'm Director of Engineering at Lofty. Lofty's a software consultancy in Fayetteville. Again, there's some of you may not, it may be your first time, or maybe you just haven't spoken with us. I'm there. Casey, who's in the chat, is also from Lofty, and we help coordinate these meetups with Chrissy, or Casey does. So glad to have you here. I'm a part of the mess that is the podcast that our software consultancy produces, called Friday Afternoon Deploy. And if you've not heard it, you should check it out, friday.hirelofty.com. It's actually a great resource these days because so many people are full remote that perhaps weren't before, and maybe you're missing kind of the ability to sit around with other developers and complain about JavaScript, or complain about Python, or complain about Docker or anything like that. You can come listen to us complain and be like, absolutely, I totally agree with that, or no, you guys are idiots. And you can say that out loud, or then leave a comment anywhere, or just email us, because there's my email. You can send your hate mail there. But we're
get a lot more of the latter, a lot
yeah.
more hate than the agreement.
So yeah, anywhere I'm social, I'm at Tyrel Denison. So you can find me there as well. Oh, that's not it. There we go. Maps, what are they? Everybody loves maps these days. Part of, as data is becoming far more like the key to everything in the minds of a lot of people, and realistically it is providing so much insight around so many things, to be just super vague and businessy. Ways to visualize your data are key, and maps are a great way to do that. Everybody loves when you're asked to produce a heat map, or things like that. And pictures do, pictures speak of 1,000 words. Pictures, that. That's a very true statement. Like, you can visually understand things more significantly than you can with a lot of words. And so there's something powerful about being able to visualize things. And so the good news is, as Python developers, and this tool is certainly not just used for visualizations. In fact, it's way more powerful than that. And we'll only talk about the visualizations there towards the end. But most of the time, the ask would be like, can we get that on a map from a client or a stakeholder in a company? And for the tools like that, we've got GeoDjango. And I don't know if any of you have experience with GeoDjango yet. We had some minimal experience with it prior to a couple clients ago that really came in and needed to leverage a lot of geospatial information. And the great news is Django had GeoDjango built in the contribs. And so To kind of give you the straight from the docs version of GeoDjango, you can read along with me. GeoDjango intends to be a world-class geographic web framework. Its goal is to make it as easy as possible to build GIS web applications and harness the power of spatial-enabled data. This is the way they do it. You get Django model fields with OGC geometries and raster data. You get extensions to Django's ORM for querying and manipulating spatial data. It loosely couples high-level Python interfaces with GIS geometry and raster operations and data manipulations in different formats. And it gives you the ability to edit geometry fields from the admin. So you're probably going, what the heck was all of that? And that's understandable, because when you enter the world of GIS, there's so many acronyms, so many, there's just a language to it. And I mean, we're kind of accustomed to that as developers, but anytime you enter into a new sphere, you're like, oh, I've got so many acronyms and words to learn now to be able to speak the language of this niche market or this technology. And so the same is true with GIS software and things of that nature. So I will do my best to debunk those as we go along. Bear with me along the journey if I skip something or don't immediately tell you what it means. I'm pretty sure I answered most of those questions through the course of the talk, and obviously we can chat after and have a Q&A and talk about stuff. So I mentioned OGC, that's the Open Geospatial Consortium. Basically, it's the open source-ish body that determines how we are united around geospatial information, kind of like Latin long and other things that we'll go into, like SRIDs and things like that. But basically, they're the governing body that kind of keep everybody unified around geospatial data. Next is GIS. You may not have heard of that. That's Geographic Information Systems. And that's super broad. It kind of can be thought of, like for me initially, I heard GIS and heard it tied immediately to PostGIS, which we'll get into in a minute. And I just assumed like, that's it, that's the term, that's the thing, that's a really specific term now, but it's not. It's really broad, but it refers to systems that deal with geospatial data, geographical information systems. So looking at the components of a GeoDjango app, there's that PostGIS I was talking about. PostGIS databases. A PostGIS database, thankfully for all of us, is nothing more than a Postgres database with the PostGIS extension installed. And that gives you some methods. There's some topology stuff that gets added on there that GeoDjango doesn't take advantage of. But once you get that extension bolted onto PostGIS, to Postgres, excuse me, you now have a PostGIS database, and everything goes exactly the same with a handful of extra functions that you can run at the PostGIS level. Thankfully for us, we're working in Django. Those PostGIS functions are wrapped up in ORM functions that we'll go into in a little bit. But then there's also like a basic app configuration that has to take place. So if you'll bear with me, we're going to try and hop over here to some sample-ish code. You're in my editor with me now, right? Can I get a thumbs up or something? Sweet, sweet. Okay, cool. So looking up here, this is, I mean, it's for setting up your database. Once you've got that extension installed, it's as simple as defining your backend there. Again, like I had mentioned, it's baked in. So it's Django contrib. Let me see if I can increase the font size on this real quick. View, enhance. Enhance. Where's my enhance button?
I think it's Command plus in code.
That would make the most sense, wouldn't it? Enhance, enhance.
It's just Chrome.
Enhance.
Just Chrome.
Okay. So, yeah, so right there in the contrib, you have a GIS, which is where all of that stuff's going to live. You get your DB backends, PostGIS, and there's actually several different geospatial adapters that GeoDjango has, but the lion's share of people working in Django are doing it in Postgres. So that's what I've built my stuff in for this example, what we've built our production code in, and what most people will kind of be most familiar with. And then additionally, you'll just need to have it defined in your installed app and add that contrib.gis to your installed apps. And that's the basics of what you need to like have that kind of functionality in place. Obviously, the basics barely get you started. There's a tutorial that is super helpful. That's on the main Django project website about GeoDjango, and we'll see more kind of examples that were birthed there and were implemented in the code I've got here. But you can go read there, and the warning I'll give you is they talk about it all like it's very simple, and fundamentally it is, but we're all at least marginally aware as developers that people can kind of hand wave things that are more complex. Like once you understand it, it's rather simple, but on initial builds, it's far more complex. So you'll have stuff you'll run into, like you might have fun getting that extension installed in Postgres or things like that. But we'll go through kind of all the shapes of a GeoDjango app through the course of the tutorial. So you can kind of see how it shifts a Django app and what to do with different things. But backing up and looking at kind of the key stuff you want to deal with here is geospatial data. If you didn't have geospatial data, you wouldn't be using GeoDjango anyway. So there's different formats for geospatial data. GeoJSON is increasingly becoming popular. A lot of tools use it, especially with the spa apps that people are building that are geospatially aware and things like that. It's pretty performant, and obviously JSON is consuming the world along with JavaScript, so that's a pretty regular format. GeoPackages is another one that can be ingested. GeoPackages are basically SQLite databases that are spatially aware, so those are really cool. You can actually query those in place and do things with that. But a GeoPackage is basically a packaged SQLite database that knows what a Latin long is, so to speak. But the most common one you'll run into if you're dealing with geospatial data are shapefiles. And shapefiles are basically, Evan's just nodding along in pain. I see that pain, brother. Shapefiles are basically the Internet Explorer of geospatial data. They've been here forever. Everyone uses them. They're ubiquitous, and they bring you nothing but pain. But it's what you get. And the data that I've built my app around, to give some context early, is the Kaggle COVID-19 data set for confirmed cases globally of COVID-19. How apropos, I know. But it's a shapefile. It's like, okay, Kaggle's sending me a shapefile. I believe they have it in a couple different formats, but the easiest one to grab was those good old shapefiles. Fun fact, a shapefile is not a file. Shapefile is 4 to 5 files in a folder. Hopefully zipped, often not. You can see the breakdown of a gesture to my second monitor, like you can see it. A shapefile is composed of .shp, shx, dbf, and prj. There's another one that I've forgotten off the top of my head that this is like optional, I think. But you can also tuck that information in one of the other files. It's a good time. But all of those files are necessary. They all basically are referenced by that initial .shp file. So you can't just kind of pluck one out. When you parse the code, and we'll look at that here in a second when we ingest a shape file and kind of look at it for a minute, it's all required. You'll only parse the shape file, the .shp, but that shape file references data and all those others, so they all have to be there. It's just a good time all around. But yeah, if you're working with geospatial data, get used to shape files. You'll be there with them for a while. So we talked about getting into those shape files and different things. So when we talk about shape files, geospatial data, layers is kind of the default term, the layers of a shape file. And that's what we're gonna hop into now. But to do that, I've got to introduce you to some more jargon and tools. Specifically, GDAL and ORG. They are painful, but they are very useful. And if you've got any experience with them, you know exactly what I'm talking about. GDAL stands for Geospatial Data Abstraction Library, and it's a C library that is very fast, very efficient. Thankfully, we can interface with it with things like Python, but you also can use it from your bash shell or your C shell or your terminal, and I'll show you that in just a minute. But that's a great way to get into there. And then also ORG, which, fun fact, ORG stands for literally nothing now. Once upon a time, ORG had a significant meaning. ORG now technically stands for Simple Features Library. because the meaning of the acronym has been lost, but they decided to keep it anyway. But Simple Features Library, aka ORG, is a vector library that's basically absorbed into GDAL, and they're highly linked now. So the way you ingest geospatial data is through layer mapping. You go through a layer and you look at it and you find the corresponding data connections, or you look at basically what is the schema of that feature, and then you create a corresponding feature, and we'll do that here in a second, now that we are at our fun demo time. So come along with me into my terminal, and we are going to go first. Let me think where I am. I'm going to go into COVID demo cases, data. We're going to look at the constituent. Oh, I actually want to do this instead. Yeah, that's better. See, this is why you always have to tempt the talk gods and try and do stuff live. Yeah, that's where I want to be. Invalid argument. Can you not pop D in this? Can I not pop D in this? All right. I'll just change directory there like a farmer. All right, so.
Hey, Tyrel, you might bump your font size just a little.
Yep, thanks again. Wait, command plus 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 plus. Perfect. So inside that is a shapefile. That is one shapefile with an extra XML. And I think everything else is key to a shapefile that's in there. So those are the constituent pieces of a shapefile. Now that we're there, we'll back out of it and bust out some tools to explore that data. GR info. Why are you complaining? So this is why we always do.
You're in the COVID demo directory.
Thank you, sir.
Yeah, and you've got ORG info instead of OGR info.
Awesome.
It's like a code review session.
It is, exactly. Let's try that again. So OGR info, COVID demo, cases, data. And we want the unique.shape. There. So we got one layer. The basic info will go in and introspect that and tell us what our layer is. And that's one layer. We see here it's called a unique geocoded matches, and it's point data. And we'll go into the geometries of shapefiles or geospatial data on the other side of this. But first, let's take a dive into that layer and see what we get. And here we are. So this are the constituent pieces of the geospatial data in that shapefile. At the very top is defined as a geometry. The feature count is how many features are in that shapefile. Basically, think of features as a single row of data. And then you'll see there's things mentioned here, like WKT and all of that will go into as well. Again, lots of jargon, but then you'll see underneath it, the score, match address, long label. Those are basically attributes on that point, on that geospatial area. So if we were looking at a circle, which would be a polygon, and I'll go in that in a moment. Obviously, like everybody understands conceptually it's a polygon, but that's actually a field type within this kind of data. So if we were looking at a circle and we wanted to describe the color of that, we would say color blue and things like that amongst these fields. So those are all descriptors of that point. So for the COVID data, this is an address that matches that confirmed case. That's the Latin long. It's the country of origin. That's the country it's in. The rank. All of those are data points around that Latin long. So that's basically what all of the data that's within our excuse me, our data set that we're exploring. So that is at its basics how that goes. Let's look to, one second. I want to go to my model file here. So basically what I've done, and I'll swap back and show you again, I've taken this and used it, it's the schema of the feature, and created a model off of that. You can see here, they're basically correlated. I even use the max length and things like that defined in that file. You go along and create your model, and then here is the geospatial field. You'll notice that the model I'm using is not the standard model, it's the gis.db model. So it's still, sorry about that, it's still in your class, you're inheriting from models.model, but your models is different. So you're importing a different models there. So that can be confusing if you don't notice the import, because that differs. But with that model, you get all your geometry fields as well. So I hand baked this one. It's kind of good to do. It gets you familiar with your data. If you're in a hurry, you can use something called OGR inspect. OGR inspect, and I'll give you the example here, will generate a models file for you and give you the dictionary that it generated on your behalf. Basically, here's the mapping. Once you've got those model files, you can run a load script, which I've created here, that basically takes that mapping, either the one that I've hand mapped here or the one that's in the model file that OGR inspect creates, and you point it to the shapefile you want to ingest and just run it. Just call it into your Python shell and run it, and it will execute and parse that entire data set for you and store it into your database. So that's basically layering at a high level. But now we're gonna have some fun, talk about geometries. So with those geometries we mentioned, we have point data, which is a lat and a long, and that's what we're examining in this example, because we're looking at the point of a confirmed case of COVID-19. There are multi-points. So if there are a cluster of points that you want to associate with one thing, there's a multi-point data type. There are polygons, which are multiple points that have a linear relationship that basically create a non-stop shape, whether that be a circle or a square or any number of polygons, but it is a solid area. So it's referenced like a polygon would be. For those who want to have negative space within a polygon, they have multi-polygons. So think of circle versus donut in this case. Your polygon within the polygon represents a negative space, just in case you like polygons inside your polygon. Then we have line strings, which are basically how roads would be created. So that's a linear connection between points that does not create a completed polygon. The shape's not complete in that regard. So that's the basics of geometries that are supported within GeoDjango. There are a lot more geometries available, but those are the ones that GeoDjango supports out of the box. So some fun facts. There is, for every field, every geometry, you have what's called the SRID, or Spatial Reference System Identifier. And basically there's different ways to kind of interpret the points within that geospatial area, particularly when you're looking at geographical stuff. When we're looking at geometries just in the purely geometric sense, those things aren't relevant. We'll get into that in just a second. But say you're looking at you want a very accurate depiction of, say, a spot in Texas, there are SRIDs that are highly trained or highly defined around Texas versus more broad ones. So for example, if I click out of here and go and look at our data here, we see the SRID on this one is 4326, which is basically like the most accurate US like most general US SRID. That's the default you get with GeoDjango, and it's the most commonly used for like a broad swath of geometry, of geographies within this stuff. And then you also have the issue of geometry versus geography, because you can store geometries within these things, because that's purely what they are. It's when you take that geographic element and add things to it, that things are computed differently. So like distances with geometries are not calculated. I forget the metric, the unit of unit of measurement for geometries, but when you are using geographies, you're obviously getting either kilometers or miles, and you can specify that. As well as geography is measured on a spherical plane, geometries are measured on a Cartesian plane. So, and then SRIDs as well can kind of differ. Like if you're doing like flat Earth maps, no flat Earth jokes here. If you're calculating your distances on a flat Earth map, you would use a different SRID than if you were looking at spherical distances or globes. All of those, like when you're looking for extreme precision, are really important. And so you have the ability to get that precise with your geometries. So there's different supported return types from GeoDjango. You can have, so if you were to ask for that point back, you would by default get what's known as the well-known text. Those are supposed to say known, not no. I apologize. Typing is hard. Well-known text, which is just a string representation of those Latin long coordinates. And then there's the binary representation of that as well, which is the well-known binary. You can also ask for the extended well-known text or binary, which will include the SRID for the like most accurate. What exactly is this point here? It will give you the Latin long and the SRID, so that if you're concerned about getting conflicting data that's using a different SRID than the data you stored, you can cast and things like that. And then GeoJSON is another like standard, get this out of the box kind of thing. And it's increasing in popularity, and hopefully it becomes kind of the de facto, but we'll see where we get. Now it's time for more demos, y'all, because everyone loves to watch me try and code in front of you all. So we're going to take a look at a few things in the demos. We're going to look at admin, because admin gives you a ton of stuff out of the box. We're going to look at REST.js. REST framework, of course, is everywhere. If you're a Django developer, you got to have an API, and there's a GIS aware library for that. And then we'll see if we can come up with some fun queries to run. And I didn't actually have this on here because I wasn't sure that I was going to be able to get it working, but I've actually got a front end slapped on it too. Pretty stoked about that. So we'll kind of go through all of that stuff. And that concludes the presentation portion. Now you all get to watch me share my screen and futz around with files and things of that nature. So jumping back over here, we've looked at the model file. We've looked at, my mouse is the worst. So I talked about admin being great. To bring in the geospatially aware admin, all you have to do is inherit it, make it inherit from geomodel admin, and you'll get a ton of stuff out of the box. So let's take a look at that. Avert your eyes. Don't look at the API yet. We're not to the API yet. All right, we're in admin. So the cases here in admin are that data set I parsed. You can go in here and look at all of these. So let's look at Ramshaw. So here's the data that we got off of that based on that mapping. See that Ramshaw is in Minnesota in the US. It's technically in a village, or is a village. It's got a score of 71, and I honestly don't recall what the score is. But you can see there's string representations of the XY that are varying degrees of precision. Those came in that way. The Django admin's kind of obfuscating a little of that for us. But then you'll see here, this is the the neat part. You get a built-in map to display your point right there in admin. If we zoom out, we'll see where in Minnesota that guy is. Pretty far north. And then one of the fun tools you get out of the box is to say, like, no, that's not where Ramshaw is. Ramshaw's over here. I'm going to say new point. I'm going to save it. We're good. We've redefined that Latin long within admin. It's a powerful tool, so be careful with it. If it were a polygon, I'm sure you saw here, look at all of France. That's good. France County, France in France. Is it? Yep, it's France, dead center of France. So there's a polygon editing tool here. If this were a polygon instead of a point, you could draw a polygon, and that would be saved to the database as well. So pretty cool stuff you get just straight out of the box with Django admin. Jumping back over to the code. Let's see here. Oh, serializers. We talked about REST Framework GIS. You have a geo feature model serializer. You pass that in and inherit from that. Be sure to specify what your geo field is, and then specify what all fields you want to include in that serializer. And that will generate valid GeoJSON to you instantly. That's super helpful to connect to your front ends, which we'll see in a minute. Obviously, you'll need to connect it to a view. For this one, I've added some additional stuff here. Obviously just normal view set stuff, but more specifically, I've added a bounding box filter that'll be used to the REST API so that you can send a bounding box, which a bounding box is just a polygon. Like, I want to look at everything within these points, basically creating a radius by which to search against, and that can work. And then this data set was like 5 gigs of data, and I had to scope it down. So I've done that, but I've got the full view that I hope to be able to show you and not crash my Zoom meeting with the big case view in a little bit without that slice. Where else did I need to go, or want to go rather? One last file. Let's see here. Well, in my demo, REST I've talked about. So I'll show you the REST API real quick. As I futz around with, there we are. So you've seen admin. Now we'll go over to the API. We hit cases. And here is that truncated Wuhan, of course, scores the highest. Typical Wuhan. You have valid geodation here. This is what it looks like. It's a feature with the geometry of a type point and your coordinates, and then all the properties that go along there. Just in case we can't see that. Always bigger, always bigger. Hopefully that's helpful for anybody needing to see it that can't. But yeah, get that full thing in screen. So that's what a defined point of our data in GeoJSON looks like. All your standard queries would work, rank and things like that. Like, you search by all of your basic properties. But then you can also, and I'm going to do this on, I've got to do it on big cases because, come back. Because otherwise it won't, one sec. It doesn't like you can't filter when you've sliced. And I've sliced for the sake of, I tried to use the pagination. There's a pagination tool for it. Couldn't get that working in the midst of my scrambling to get a demo app completely feature complete before this demo. So it is what it is. But now I'm going to hit this endpoint with a bounding box. Bring this back over. And So now we've scoped to that bounding box. So you see, we're in Mississippi now. We're no longer looking at China. So that's a great way to take from your front end, should a user through their JavaScript create a bounding box on the front end and want to limit the data that way. It's real responsive. I mean, you guys saw how quick that was. So it works really well. And then you've also got ORM queries that you can utilize, and I'll show you some kind of examples of those. I tried to find like the geographical bounds of some places like Bentonville and Fayetteville and places like that, but it's hard to just kind of Google and find the like, give me the geography lat long of this place. If you know of a way to get that, please tell me, because that would be fun to play with.
When you find it, it's almost definitely going to be in shapefile format too.
Yeah, that's also very true.
It is in shapefiles.
So I wasn't able to find a nice bounding box per se beyond that for us to write into an ORM query. But so I'll pull up some example docs here that I've kind of hashed out and made my own, so that we won't run them in the terminal. I apologize, but you'll get the basic principle. So you define a point. If you wanted to, you can just make instances of these classes, obviously. So a GIS geos point, and you put in a Latin long, and then you can say get polygon by polygon contains point. And so you would be filtering the polygons by those that contain a specified point. Or in this case, with our code, we would do cases. And we can do this, the inverse of this, because the syntax allows you to specify with the ORM queries, you specify the field, and then there's a lookup. There's a list of spatial lookups that you get. And so for this one, our field is called point. So it'd be get point, and then we're using the within lookup because we would want, since we're looking at point data, we would say, give me the point within this boundary or this polygon. Give me all of the points within this polygon. So that's how an ORM, this would, or it would be a filter, not a get, because there'll be more than one. Gilter, yeah. So that's how that would work as far as those go. And then additionally, you can do distance queries. So you can say, give me the point for a case with a point of distance less than, and then you specify the point you want for comparison and set that distance. Like for this one, it's 7K. This one would be 7K as well, just without the kilometers. So you can look at distances differently that way. So again, that's not going to run in my console. So sorry, we can try and do that, but I think it'll be more fun to try and watch my Dockers blow up when I try and ingest all the data sets of this thing and put it on a map. So we'll do that next. Let me see. So yeah, looking at how we would institute a front end just in Django, because there are a lot of tools for visualizing data. It's kind of what I started off with, was talking about how everybody loves visualized geospatial data. One way to do that that's got almost out of the box support for Django is using Leaflet. So, oh, Evan's the man. That's great. I gotta find, we'll look at that in a minute. So you would use Leaflet. So this is a Django template that I've created that creates a Leaflet map. You've got some Leaflet.js. You would install Leaflet, pip install, include it in your installed apps, and then you can use it instantly. I went straight to the CDN version of these libraries, but you can npm install them and do that if that's your preference. And so down here is where down here's where I render the map. Leaflet map, I'm calling it US. I'm giving a callback method that is defined here. And that function, excuse me, is a standard one. Takes the map and the options. I've specified where the API is that I've created in GeoJSON or GeoDjango. No, REST framework. That's the one. And then it makes that call and populates it on the front end. So if we look here, we have a nice map. I call it US because I centered it on Kansas, which is, I looked for the geographical center of the US and they gave me that. So there we are. We'll back it up one right there. My zoom's probably, and you set your zoom and your center within the settings.py file for leaflet so that when it loads, it'll be there. But then you can see that this actually also has the information. United States, that's a poorly named data entry, but you can see New Mexico here. That's Deer Run #1, Colonia. So the Fig, I'm guessing that's a city in North Carolina. To Run. Some of these are at the state level. I parsed in the proper name, I believe is the field. Let me see. What did I tell it?
Place name?
Place name, that's it, yep. So you've got those on all of those points. And then if we hop out, I limited this data set to 100. So that's 100 points off of that data set on a map. And I did that work probably in an hour, maybe. The hardest part was forgetting to put the .json at the end of my URL because it tripped everything up when I didn't specify that, and Casey pointed that out to me. So he got some coming to the rescue points there, and that helped a lot. Because I done all the work and I was like, it doesn't, I could get it in the DOM and I would look and say like, it's pulled it into the DOM, it's rendered, it's a 200, the data's there, why isn't it displaying? But all the JavaScript wanted my URL to end with .js instead of just the view set. So lesson learned there. But the good news is that also freed it up to work on another tool. So this is Leaflet. Leaflet's great and it works really well with Django. To make something more robust though, there's a tool called DeckGL. And along that is another tool called Kepler. DeckGL is a point rendering tool written completely in JavaScript and WebAssembly more specifically, or more accurately, not JavaScript. So it can render a ton of data points. Kepler is a tool that sits on top of DeckGL and gives you a lot of power. And so what we're going to do now is ingest. There's that same data set here in Kepler. We've got an instance of Kepler running in one of our Kubernetes clusters. So that looks pretty cool. And you can change some stuff. You can zoom in. But the real power of Kepler is with a lot more data. So what we're going to do now is try and melt my computer by hitting that big data endpoint. And everybody loves big data, right? So let's see how long this will take and what color the smoke is.
Don't forget your .json.
See, he's too good to me.
That's what I'm here for.
You all need a colleague and boss like Casey Kinsey. Willing to push that talk button.
What I can't
Save your butt.
Yeah,
So you don't just watch that.
My
spam.
mouse battery went dead 5 minutes ago, but I'm still pulling through.
Hanging there like a champ. So we're gonna let that pull out of the back end of my little computer here. But it should be around sometime in the near future.
While we're waiting, I have a quick question. I'm not
Sure.
a Django guy. So the first two, one, a view in Django is essentially a controller, right?
Correct. Yep.
Okay, I wanted to
Django
clarify
was
that.
really dumb. And they said, hey, everybody's calling that thing a model view controller. You know what's cooler than that? MTV.
Right.
I freaking love the real world.
Yeah.
So it's MTV in Django. And decided
The
to
other
completely
the
buck-
other is so I'm currently in Rails land right now, and
Yeah.
I was curious, does Django do something kind of neat like where you within a single function you can specify templates, I guess in the Django sense, based off of the type, like you just appended a .json to that call. did you have to do something in your routing to say go here if my type is JSON?
Not in that one, but it doesn't have the response to like Rails does. That's one thing I miss as a former Rails developer. Is
Yeah.
having a response to where you can .json or .csv. There's not that kind of magic in Django, but the .json works, and we're all really happy for it.
You do have that kind of magic though in DRF.
What's that now?
You do have that kind of magic in DRF.
Do you, and DRF? Yeah, DRF does handle that for you. That's
You
right.
have it like you can pass a format query string parameter to DRF, or you can do a .json, but it's not.
Or request header.
Yeah, it's not quite as easy at like the controller level though, where you can like very easily trigger that logic. But you can pass it through and access it on that on the code side.
I didn't have my network up to see before it was too late.
Don't give up, Tyrel. Don't give up on it. Python's not very good at serializing 100,000 rows of JSON.
I'm giving her all she's got, Captain. It's my best Scotty. It's not very good. I apologize. But you can definitely hear my fans kicking on this bad boy.
Is it a MacBook Pro?
It is indeed.
16, 15 inch? What are we?
17? Is that a thing? Is that
16
yeah.
is the biggest now.
Well, then it's
Does
not.
it have the escape key, the physical escape key?
It does not.
No, yours-
Okay, so it's the 15.
15. It's a
Yeah,
15.
15, yeah.
It's a 15. Man,
It's cooking.
it is.
not
Is
Network.
it a?
The
It's
visual is
all-
so worth it. The payoff is great if we can get there.
It's
So
all
is it-
Cat Nation.
Is it?
Boom!
Oh, okay.
Hell
I was
yeah.
gonna say,
There it
did
is.
the REST call take that long, or was it Kepler
Little of both.
ingesting it?
Mostly
Yeah.
the rest all on my sad little machine trying to do all that.
I
So
think it took that long to cook the cookie.
Yeah,
Or
I mean,
not
we
a
did
REST
this-
timeout thing?
we did something similar on a project using this exact stack with DeckGL on top of it, and something like this, that many rows, it's all JSON serialization in
It's the
Python.
JSON serialization that's the expensive
Turning
part
it
of
to
that.
GeoJSON. You can do JSON serialization with PostGIS. It gives you functions for that, and this same type of thing you can get down to like sub 2 second.
Yeah.
If you do it directly in the query. So that's
That's
a
yeah.
future optimization if you need to render this kind of volume of data.
And that's what we've done on the other app is we wrote that all in SQL. Just for the JSON rendering for the front end when you're dealing with this many points of data. Because I mean, that's a lot, as you can tell. Let me see. Casey, you're better at playing with Kepler than I am. What do I need to do to make this thing really cool?
Make it look you want it to look really badass.
Make it real fancy, yeah.
Yeah, open that thing up. Open that layer and then leave it as GeoJSON, and then underneath the color, do color based on, and then select some numeric field from the GeoJSON.
Score, obviously. Score or rank. What do we think? Anybody?
I don't know what either of them.
Do
mean in
rank.
this
That'll be
context.
interesting. You'll see how they're ranked, but how that plays out geographically. And then pick a more robust color palette. Something, I think they have some ones with broader colors, or pick a divergent one where you've got like,
Oh yeah, really highly divergent color pattern.
pick two opposing colors with a neutral in the middle. I think it's the third grouping of colors.
Go that guy. Oh, I see what you're saying.
That one's just dissonant. Yeah, if you go all the way down, you should get like a red to green. Yeah, go up two bars from there.
You want this guy? Oh yeah.
So your low rank stuff's gonna be red. Your high rank stuff's gonna be in green.
So all of that data pops up there.
Of course, that all comes back to the esoterics of that data set and what value. I don't know what they're calling rank in that data set,
Right.
but there you go. That's how you make it look cool as shit.
That's how you get that VC money, y'all. Next up, profit. Who wants to go in? I'll sell you this app for like $3,000 right now. Dockerize it, send it to you.
Set your
You can
radius.
send it to your cousin who works as a lawyer in DC. got the COVID-19 data set right in there, you're ready to go.
Look at the radius based on, and set the radius based on score. They may be highly correlated.
That's a bit much.
Yeah. No, they're not correlated. Otherwise,
No, you're right.
your bigger ones would all be the same color.
I'd be interested to know what the difference is there then.
It's better when the radiuses are smaller.
Yeah. So Kepler's
So that-
a really fun tool for playing with this kind of data. And you can build very comparable stuff using DeckGL, and we use Vue. That's our JavaScript front end of choice. So we've replicated a lot of these features with Vue and DeckGL and Mapbox for the underlying mapping. But again, that's all rendered from the little Django app I've got running in a Docker box on my local machine. So there's definitely a lot of power there. And again, like there's a ramp up time with just kind of understanding all the esoterics of the information. But once you get them, the technology is there to help you move pretty quickly. So that's what I got. And I'm glad to chat about any of it. And yeah, thanks for listening. Thanks for coming to my TED Talk, as they say.
Cool. Thanks, Tyrel.
Yep.
Can we give you is it weird to give you like a virtual round of applause?
It's very weird.
Everybody clap into your microphones. I can't because I'm using push to talk and I have my hand on my space bar. Okay. Awesome. You got Tyrel, you got some time to do some questions if anyone's
Yeah, for sure.
All right, lay it on him.
Have you looked at the John Hopkins data set, that map, that dashboard they have?
Yes.
Do you think they're using something similar? I don't know if they're because it's an open source thing, isn't it?
I think they're using ArcGIS. ArcGIS
That's
is really
Esri.
common.
That's that Esri tool.
Okay.
Which is ArcGIS. ArcGIS
Yeah.
is.
Yep.
It's the same one it's the same dashboarding tool. Like if you go to the city of Fayetteville, they use those Esri tools for mapping out ward boundaries and the trail system. It's all in ArcGIS. That's a really
Yeah, ArcGIS is the shapefile of geospatial.
same company.
visualization.
ArcGIS is the tool, and Esri also made the shapefile.
Yeah, exactly. So there's a lot of prior art there and data and all of that, so it gets heavily utilized. Oh, Bobby's got. Oh, nice. So apparently John Hopkins has their stuff on Git, so you can pull it.
That's pretty cool. I don't care if it's not in shapefile format. That's better. I'd rather parse it out of a CSV than touch a shapefile.
Yeah, so tools like Kepler require your stuff be in a JSON file, a GeoJSON rather than a shapefile. So thankfully, with REST framework GIS, we get GeoJSON right out of the app. So you just hit the endpoint into your app there, and it pulls it right in. So.
My question is, when was someone going to tell me that I spelled my own name wrong in the chat today? Pretty bad.
Oh, Kindsey. I didn't see
That's
that.
pretty bad. Casey Kind. That's why I'm wearing my hat. I'm incognito. Dang
No
it.
one would have known it was you
Question
otherwise.
for you, Tyrel. I was going to toss you one, and then I saw my own name, and I completely lost my train of thought.
That's fine.
I'll come back if it comes back around.
Yeah, sure. And I'd like to eventually clean this up a bit and make it available on the Lofty GitHub account, so that folks can pull it down and play with it on their own. There's some noise in here that I would want to get rid of, and flailing and things like that. But eventually, I'd want to I'll do a slide share and get you guys all this stuff, so that all you have to do is Docker compose up and have yourself a geo tool to play with. But
Tyrel, can you maybe just elaborate a little bit on what you're able to do with DeckGL? So DeckGL is a framework that runs on the GPU to render like highly graphical map stuff.
Mm.
Kepler is a data exploration tool that you just showed us that's built with DeckGL. So it
Yes.
used the DeckGL framework and then implemented tools to like look at data sets and change colors based on values.
Right.
Can you maybe just elaborate a little bit on like what you can do with layering and you know, adding also polygons to with like DeckGL? Like what kind of visualizations can you do with that beyond putting points on a map?
Sure. So actually, this is fun. Now we're in 3D mode.
Oh, you're not shared anymore.
Oh, wow, that's disappointing. So to kind of explore further with the tool we have here, I've put it in 3D mode. And if I chose to, let me see if I can extrude height based on score, maybe, rather than radius.
I'm
think, Casey?
pretty sure Kepler's extrude tool only lets you apply it to
Radius?
polys. I don't think you can do it on point fields.
Lame.
I
All
know.
right. So there, we're better. We beat Kepler. Deal with it. So the DeckGL framework allows you to do a lot of stuff in regards to adding like extra dimensions, 3 dimensions to your data. So for example, you can set a height based on a value. So you can and then set a corresponding color based on that too. So there's really amazing ways to kind of look at what's going on in a region, to where you can get in there and see a lot of detail and communicate some really powerful stuff. And that's not, and with even within, I'm trying to think. I've seen it play out. Oh, no, I'm sorry. So one thing we've done to kind of represent granular stuff within a larger context is we create a polygon that covers an area, and then we take data within that polygon and break that into smaller subsections of that data. Basically, we grid a polygon so that there's data within each of those grids that conveys meaning within that context of that polygon. And then we can color and introduce attributes like height within that polygon. So it's one thing to just have like stuff at a single polygon level that gives you meaning, but when you can within that polygon have subsets of data that also change, it becomes really powerful. And so you can use your external polygon to define a region and set some boundaries and some lines, literally boundaries. But then also on top of that, because it renders in layers, you render additional layers in there that show meaningful data at a more succinct geographical space that can give you a lot of meaning about one polygon rather than just comparing polygons. So when you can stack data like that, you can also stack points within those polygons, so that you can look at all of the stuff within a specific region. So creating bounding boxes kind of out the gate are really great as well. Is that kind of,
Yeah, sure.
kind of hitting on the stuff you're wanting me to cover?
Yeah, I mean you can
Highlight.
you can stack them in layers, which lets you, I mean, do all kinds. I mean, you could show people maybe even just toggling the visibility of that layer in Kepler off and on. The little eyeball on the left side of, up there where the purple mark is.
That's trash. Hold on.
The next one down.
Oh yeah, this guy.
Yeah. So you can see how quickly DeckGL, I mean, that's rendering 100,000 points off and on like that. So if you can imagine, that's just one layer. So now imagine building a UI that stacks multiple layers on top of each other that you can flip off and on that quickly. And you could start to imagine the ability to, overlay data sets. You can set transparency based on values. And so you could put transparent layers on top of satellite data. So you can see the underlying topography underneath it. And then there's like a whole bunch of that we haven't even messed with in any of our products, but animation. So DeckGL was open sourced by Uber. Yeah, and Uber can animate a billion cab rides in New York City and draw out every route and play it with this software, which is really, really cool.
And the way it does that is it basically it creates those layers, and then rather than destroying them and putting them back, it toggles the visibility on and off. So and that's the beauty of being able to write all that in WebAssembly, is to be able to do those kinds of things, keep them around, persist them, change them visually, without having to repaint the DOM. Like, well, I mean, technically it would be repainting the DOM. This is where I'm going to get over my skis talking JavaScript and DOM, but without having to recreate things in the DOM, simply toggling them off visually. Let's see. Bobby says, can I change how many points or groupings based on how zoomed in to limit? So you can do clustering. That'd be clustering, and I believe it may have some clustering built in. We were considering making our own clustering at some point, and we weren't finding the clustering tools we were looking for originally. But I believe there's some clustering in there. Pyramiding. Okay, I have not heard that term, so it's quite possible. I'll Google that shortly.
I know
I'm not
that
sharing my
they
screen.
use the word pyramid for when there's like a broad overall view, and then if you zoom into one particular section, instead of seeing all, like say you've got 9 sections that make up one layer of a pyramid, to look at the generalized, less data passed over the internet version, you're looking at one layer, but you can drill down into layers deeper. So it's sort of similar.
Yeah, sounds very similar. Now that you're not looking at my screen, I'm going to research that word.
Tyrel, if you'll let me, I'll brag on you and share my screen. I pulled up. I think I've got the right thing here.
That is very true, Bobby. Half the battle is knowing when to Google.
So this is a product. Can you guys see this?
It's looking sweet.
Yeah, this is a product that Tyrel's and Tyrel and his team here at Lofty have been working on for one of our customers. So kind of a less abstract, more practical application. It's in farming. So you can see here that they're using this is using DeckGL embedded in our View app with Django on the back end, and it's using polygons here to represent the boundaries of individual farms. And to be able to see that against satellite imagery, it becomes really clear what this data is representing, right? That's a strong visual tool. And I'm trying to see if this is the right data set. I'm looking to see if we have more layers on this. This is our staging environment. So I was trying to pull it up. I don't know if you know, Tyrel, which one of these projects actually has some of the boxes.
Has all the goods? No, I don't offhand. It's been a while since I've been in there.
Yeah, we got a bunch.
I know we nuked everything a while back.
Yeah, there's a Lofty Southern Ag. That sounds like something I would make.
It does.
What's in this one? If I can find the right one, I can show some of that 3D extrusion and things like that. I'm not trying to hijack your Q&A though.
No.
Oh yeah, this is the one. This is the money right here. All right, cool. So let's pull up corn as a crop.
Agreed. Yeah, I agree with you there, Steve.
Corn data is usually more dense, right?
Yeah.
So let's look at their yield by elevation. Looks like information. Looks flat though. That's not what I was expecting to see.
How meticulous was it to draw out all of these polygons?
That's a great question. Honestly, the my understanding of this data is that the uh, farmers themselves usually have this data, and I think they go in and draw
Okay.
them on
They hand
their own
draw it.
fields. They bring them in. Yeah, too bad. I know that this is our staging environment, so it's got some stuff on it. This is in progress. Normally, what you can see, you can kind of see it when I close the opacity down a little bit. You can see that grid tessellation almost in here. They're little quarter acre grids within these fields. Normally, they're colored. It looks like the color scaling is not doing it correctly, but yeah. So you're drawing boundary of the fields, and then it's representing by height the elevation, and by color the yield on those fields. And so there's a lot of really cool stuff you can do with it. If you've listened to our podcast lately, you know that we're pretty high on DeckGL and have been for about 3 months now or more.
And to see kind of the stuff that Casey's talking about, I'll send the link to our sizzle reel, man.
Oh, that's a good idea. That's
our Hollywood
smart.
sizzle reel.
The sizzle reel's got some. We captured video of it. We were smart. I saw it and I said, "God, that looks like a really good app. I'm gonna get a video of it just in case we break it in staging and we can't show it off anymore." So you can go look at it on YouTube instead.
And that's what we'll do. You can have some epic music too. It's so great.
Yeah.
You're gonna go be ready to fight with William Wallace when you're done watching that thing. But yeah, it shows kind of the power of DeckGL and some other visualization we bought. It's a promo reel for the agency that we work at. But it does show the power of DeckGL and specifically the data that Casey was trying to demonstrate that we broke in staging as developers tend to do. It doesn't matter, it's staging.
That means we're shipping code, folks.
Yeah, we are.
Guys, anybody else have any questions for Tyrel?
This was pretty awesome. I hadn't had a look at GIS from a programming standpoint, but I've had some training in GIS.
What context was that in?
The local community college in California, and also I worked with it in one of my previous careers.
Okay.
Yeah. Esri ArcGIS.
Yeah. That's the one. Or QGIS is another big tool.
I've got QGIS installed on this Mac.
Yeah. That's one. So that.
Have you played with AirDOS Imagine?
No, I haven't played with that one.
Mm-mm.
They used to be pretty good. I don't know what they're like now, but I saw they still do have a tool.
So what's been interesting for us, we find ourselves as an agency pretty consistently in this niche of helping data scientists or people who've kind of taken on that role within their company replicate there's some really powerful open source tools around geospatial data or other kinds of kind of data driven things these days.
Right.
And so it allows for people to come up with a unique idea and a unique concept and a unique way to build data or work with data, which is exciting. But then they don't, through those tools, have the means to take that and offer that at scale to a customer base. And so what happens is we often have people come to us who are a conglomeration of like a couple business people or even like a full business that has some guys who are doing some skunks work stuff. And they're saying like, we've found this thing, but we can't scale it. We've got a guy with like 3 Jupyter notebooks and QGIS on his computer. And we know that he's got like great information, but this has got to scale. And so those are the problems that we find ourselves being asked to solve and are pretty excited to solve these days. But yeah, but the problem is we end up having to be competitive with tools like QGIS and Kepler and all these things. So they're just like, well, I mean, I just use it in Kepler like this. Why can't your thing do what Kepler does? It's just like, we don't have the budget of Uber, bro.
To elaborate,
build that, we can do that.
We literally had a client ask us when we were building a geo feature. They had asked for some. I don't even remember what they had specifically asked, but we looked at it, and it was going to be really ambitious, some very interactive thing on the map. And they were like, well, QGIS does it. It's open source. Just go get it. And I was like, no, it
Go look at the source
doesn't
code.
work that way. Yeah. I had 1,000 engineers that are way smarter than us working
Very
on it for 15 years. Uber does it. How much does it cost to do something like that?
Be a decacorn, then you can do this.
Yeah. So I don't know how much it costs, but I'll tell you how much they had to spend.
So awesome. Well,
Cool. Okay. Well, thanks everybody for coming out and hanging for another remote meetup. We'll keep doing them this way until, you're all living it. So that's the plan for now. And so far they've been good. I know it's kind of maybe awkward and a little bit different than normal, but these have been a lot of fun so far. So we'll look forward to doing another one. It sounds like next month we're going to be doing definitely a dot file swap, maybe a dot file talk to kick it off as well.
yeah.
If you're not familiar with that concept, then totally show up. Change your life.
Yep.
Yeah, so that'll be next month. And in the meantime, you guys, thanks for hanging out. Stay safe. And we'll see you next time. And I'll post the video of this recording probably on YouTube, on Lofty's YouTube channel, and then we'll share the link back to the meetup group. So you can share it or rewatch it or anything like that. And Tyrel, you might send your slides out and post them on there, or
Yeah.
you can get them in the video. So
Yeah, I'll get the slides out soon, and then hopefully have the code base up on GitHub here in the next I'm shooting for within a week. So we'll see.
It was very cool, Tyrell. Thank you.
Okay, thanks very much.
Good to see everyone.
Yeah, for sure.
see everybody.
Take care, guys. We'll talk to you soon.